Hello all, this will be our first tutorial video for Excel. In this video we will discuss how to conduct descriptive statistics in Excel. For this example we'll be using the same data set that we used during the second intensive weekend. Just a reminder, you can find that on Blackboard. I have the folder opened here. It's under Materials for Intensive Weekend 2. And we'll be analyzing the sample data set number 1, television, physicians, and life expectancy. So take a moment to download that and open that in Excel. You may want to pause the video until you have that open. Okay, now that we're back, let's pull up Excel. So you'll see when you open the data set, this is what it should look like. We will be looking at several variables in this example. Life expectancy, the number of people per TV, the number of people per physician, female life expectancy, and male life expectancy. Now, let's begin by first making sure that our data analysis pack is installed and ready to go in Excel. We did this in class, but it doesn't hurt to go through it again. So, first step, click on File, go down to Options. Then within Options, you want to click on Add-ins. This is where you can add in various different tool packs. For this course, all we're going to need to do is look at the Analysis tool pack. You may have additional ones, but for most of you, it should be at the top of the list. Notice that there are two different tool packs for analysis. There's the Analysis tool pack and the Analysis tool pack VBA. We'll be using the standard, straightforward Analysis tool pack. So once you've clicked on that and have that highlighted, you want to go down to where it says Manage and make sure in the pull-down menu that you have Manage Excel Add-ins. Hit Go. This will bring up another menu, and you want to make sure that you toggle the Analysis tool pack on. Once you've done that, hit OK, and you're ready to go. So now that you've added that in, sometimes it's not completely obvious that it's now usable. But let's click over to our Data Analysis tab. So if you go over to the top, you'll see Data. You can click on this. And you'll know you're good to go if on the far right you now have a Data Analysis tab that wasn't there in the past. So you want to make sure that's there. If it's not, you want to go back through the steps I just went through and make sure that that is now there. Okay. Once that's there, go ahead and click on it. You'll see that this will bring up a menu that you're going to become very, very familiar with over the next few weeks. We will be doing quite a bit of our data analysis through this. This week we're going to talk about descriptive statistics. We'll also, throughout the semester, or through the next few weeks, cover a few other ideas or a few other things in this. We'll talk a little bit about ANOVA. We'll talk a little bit about correlation. And we'll also talk a little bit about t-tests. Some of you might also be interested in regression at some point. We won't be covering that directly in this course, but that's something you want to learn more about. I'm more than happy to talk to you a bit. It's pretty straightforward, but a little more complicated than what we're going to do. I may discuss it a little bit at the very end of data analysis, just so you're familiar with what it is. But for this semester, the deepest we'll take it is t-tests and ANOVAs. But let's go back to descriptive statistics. Now, you've been reading about this throughout the week. You've been reading your book and watching some of the videos from Against All Odds. So when we're talking about descriptive statistics, really all we're going to cover this week is mean, median, and mode, variance, standard deviation, and range. So if we highlight descriptive statistics and click OK, this will bring up the next menu that allow you to start conducting data analysis with descriptive statistics. Now, as I mentioned in the intensive, one of the good things about the data analysis pack in Excel is that it will give you every single type of statistics within this. So it will calculate every form of descriptive statistics. Now, the bad thing about the Excel add-on is that it gives you everything within this. In other words, you might feel a bit overwhelmed with the amount of data it gives you. So I want to walk us through a couple of these analyses, talk about how you interpret these results, and also which results to focus on, because it's going to give you more than you even need. So let's analyze one variable first. Let's look at life expectancy and see what this data set tells us about life expectancy in these countries. So first step is in the idea of input range. So Once you see that's flashing here, that means you're able to enter the data set. Now, as a few of you pointed out in the last intensive, you can just go in and click and highlight the entire column. So you're going to click at the very top where it says life expectancy and drag all the way down to Zaire. Once you have that, you'll see that this is telling you these dollar signs, in case you're curious, that freezes it. It's not really important for this, but in case you're doing any of you have ever done some creating your own formulas know you'll get very familiar with the dollar signs. But you'll notice that it's B3, which is our label, all the way down to B54, which is Zaire. So we're generally going to keep it grouped by columns. In this case, right, we're looking at an entire column of life expectancy, but sometimes you might have data that, for some reason, the variable is on the row, and all of the all the data is entered by the row. If that happens, you want to click on rows, but for the most part, columns. You're also going to want to toggle labels in first row here. Notice because life expectancy first row, it's not going to count that as data, obviously, so you want to keep that. And I like to keep that because if you're analyzing multiple variables at once, it'll be able to keep it separate and clear what you're looking at. Now, output range you can leave alone. New worksheets you can leave alone. You can leave all of these alone. All you're really going to want to click here is summary statistics. We're not going to be talking about confidence intervals now, so just summary statistics will be fine. Once you have that, all you need to do is hit OK. And you'll notice it'll automatically take you to another sheet. But I want to point this out. When you're conducting data analysis with Excel through the tool pack, it'll put the results in a separate sheet within the same Excel book. So see here it says sheet 1. See here it says tv.xl. If we click back there, that's our data. If we click over to sheet 1, you'll see this is our output. So you may want to relabel these to keep these straight. So I'm going to double click and write LE Descriptive. That indicates that I'm looking at life expectancy descriptive statistics. So let's take a little look at the output. So I'm going to extend this column a little bit so that we can see what we're looking at. So it gives you several different things. It gives you the mean, the standard error, the median, the mode, the standard deviation, the sample variance, the kurtosis, the skewness, the range, the minimum, the maximum, the sum, and the count. Again, a lot of information. You might feel a little overwhelmed with it, but we're only going to look at a few. Let's deal first with measures of central tendency. Remember from your reading and from the videos, those are the statistics that give us a general idea, kind of paints a picture of what's most common, what's at the center, what's average about the data. In that case, there's really three variables we're going to look at: the mean, the median, and the mode, which I've highlighted. Now, as you remember from your readings, the mode is the most common score that keeps repeating. Sometimes you may not have a mode, but in this case, it's telling us that our mode is 70. That for the 40 different countries, that the life expectancy of 70 pops up the most. So as I just click back, you can see China has 70, North Korea, South Korea has 70. So you can see that's why. And we also have Turkey here with 70. So that's why 70 keeps popping up, and that's why it's considered the mode. I won't bore you with the details. We'll talk a little more about this in the discussion board and through your readings, but as we know, the mode is generally not a very accurate measure of central tendency. Instead, we want to look at the median and the mean. So notice that the median is just below 70 years, and the mean is a couple years less than that, a little over 67 years. So when I ask you to report measures of central tendency, you'll report the mode, the median, and the mean. Now, it's important to keep in mind, and to examine the relationship between the mean and the median. Remember that the mean is affected by extreme scores, meaning if there's some really, really big scores or some really, really small scores, it's going to pull that mean to the right or to the left, depending on where those scores fall. So if there are any extreme values, occasionally what will happen is, again, it'll be exaggerated one way or the other, and the median is best to be used. What I would say in this case is the mean and the median pretty close to one another, just a couple of years difference. I think you could probably go with the mean in this case. Now, let's look at measures of variability. Now remember, those are the descriptive statistics that tell us how the rest of the scores fall around that center line, right? Around that measure of central tendency, around that mean. And something else to point out when calculating the standard deviation and the variance, you can only do this with interval level data. So keep that in mind. So again, 3 measures of variability. We have our standard deviation, our sample variance, and our range. So let's look at the range for a second. So the range is the distance between the highest and the lowest score. In other words, the range of this data set is 27.5 years, which makes sense. If you look at rows 12 and 13, the minimum and the maximum, you'll see that there's 27.5 years, or close to 27.5 years between the minimum and the maximum. So let's look at the range again. Now again, similar to the mode, the range is not really a very accurate or specific measure of variability, as it's only taking into consideration two variables, or two cases, sorry, the highest and the lowest. So generally, we want to stick with the standard deviation and the variance. I'm not going to go into a lot of detail here about the difference between the two, but one thing to note is that the standard deviation is the square root of the variance, and typically we want to report the standard deviation. The variance is important, but it's usually used to calculate other measures. And since you're not going to be doing the actual, calculations out by hand, what I would suggest is just focusing on the standard deviation. Now, the meaning of standard deviation is somewhat complex. I'm not going to go into this video. Again, your book does a great job of it, and we'll talk a little bit about it on the discussion board. But really what you want to keep in mind is that the higher the standard deviation, the more variability. In other words, the wider the distribution, the further away those scores fall from that mean. This is especially useful if you're comparing two measures that are looking at or measuring the same variable. For example, let's go back to our data set for a second. We have female life expectancy and male life expectancy. Let's take a second and compare between the two. So I'm going to open up our data analysis again. Remember, click on descriptive statistics, hit OK. I'm going to delete this. So now it's highlighted in black. You can just delete it. And now I'm going to select both female life expectancy and male life expectancy. So I click on female life expectancy, go over to male life expectancy, and then drag down to make sure I include all of these cases. Now make sure, again, labels in first row is clicked, and that summary statistics is clicked. Excel is smart enough to know that because they're two separate columns, they're two separate variables. So if we hit OK, notice the new sheet popped up, and notice we have two output. Right, we have life expectancy, female life expectancy, and male life expectancy. Okay. So notice that Excel will report both of these together, but we can compare between the two. So for example, let's say we're interested in saying, do males or females live longer on average? Well, we can compare the means. So notice the mean life expectancy for females is a little under 70 years, while the mean life expectancy for males is a little under 65. So using these to compare, we can say that females in general live longer than males. However, we can't say at this point, using this information, whether or not that difference is statistically significant. In other words, whether we could say this is true of the entire world. We're going to talk a little bit more about how we can make that decision in a couple of weeks when we talk about t-tests. But for now, it looks like there's a difference between the two. You notice this holds true for median. And let's see for mode. For mode, the difference is very big, but again, modes are not all that great. Let's take a second, though, and look at variability. So we can look at standard deviation between both female life expectancy and male life expectancy. Notice that the standard deviation for female life expectancy is a little over 9 years, when for males it's a little under 7.5. In other words, the standard deviation for life expectancy is higher for females than for males. This indicates there's more variability, that women that when we look at female life expectancy, those scores are scattered more distantly or wider from that center. In other words, there's more women living longer than the average and less than the average than it is male. So when we look at males, it tends to cluster closer around that 65, that mean of 64 and a half. So we can use descriptive statistics to compare between two variables, especially when they're measured using the same standards. So in other words, when you're using that standard deviation to compare, you should only do that if they're measuring the same thing. In other words, this is measuring years. Let's go back to our data set for a second. What would not be a good idea would be use standard deviation to compare between something like people per TV and female life expectancy. Those are two very different variables, and the standard deviation can't be used to compare. Okay. One last thing, this is more technical, but I want to leave you with it. We talked a bit about it in class, but sometimes you won't always have a score for every single area, for every single respondent. For example, if we look at people per television, we get down to Tanzania, we'll notice that there's an asterisk here, meaning that there was no measurement for this. Same thing with Zaire. So the question becomes, what happens if we try to measure this, or we try to calculate descriptive statistics using the data pack? Well, let's give it a shot and see what happens. So if we hit data analysis, descriptive statistics again, hit OK. I'm going to delete that out, and then select people per TV. Label in first row is still selected. Summary statistics still selected. Hit OK. We got an error message. And it reads, descriptive statistics input range contains non-numeric data. So you can hit OK. In other words, it really, really doesn't like these asterisks. So I'm going to cancel out and talk about what do we do with these asterisks. Well, we could delete out all of Tanzania, but we do have information for life expectancy and physicians per person, so we probably want to keep those in. So really what you need to do is just hit delete and delete out those asterisks. So now it's just a completely blank cell. Do the same thing for Zaire. And this will allow Excel to analyze this data. It just didn't like those asterisks. So if we hit data analysis again, descriptive statistics one last time, everything's selected that we need. I'm going to go back and reselect people per television, even though it is still selected, just to illustrate. All the way down to Zaire. We hit OK. And notice that it has now run properly. And also notice that our count is now 38 as opposed to 40. So it just automatically knows to ignore the two countries with missing data. And again, we can look at the mean, the median, the mode, standard deviation, variance, or range. Okay. So this is a quick run through on how to conduct descriptive statistics. Make sure you watch those against all odds videos, do the reading in the textbook, as well as participate in the discussion board for a little more in-depth about how to do this. But this should be able to help you run through that first quantitative analysis assignment. If you have any questions about how to conduct descriptive statistics through Excel, don't hesitate to email me or post on the discussion board. I would suggest doing the latter, as I'm sure if you're having an issue, someone else in the class is having an issue, and we all can kind of learn from working through these things. And finally, we dealt with this a bit in class, but I just want to remind you, I'm using a PC. If you're using a Mac, there are some workarounds. There might be some issues. So if you're struggling with getting this data analysis pack running on your Mac, make sure you post in discussion boards, as several of you have figured out workarounds and can help you get to the point where you can do this analysis.